Okay, so we want to find where this function is undefined and where it does not exist. Sorry, where it's equal to 0. So the first thing we're going to do, let's do undefined first. So we know that it's undefined when this guy, x squared plus x plus 1, is equal to 0. But you'll notice that if you do the discriminant, the inside part of the square root on the quadratic formula, because this guy isn't factorable, you'll notice that you get 1 squared minus 4 times 1 times 1, which is equal to negative 3. This tells you that you have two imaginary solutions. So since this guy, for the purpose of what we're interested in, this guy is never equal to 0. So what that means is that there aren't any places where this function right here is undefined. Okay, now next thing is let's find the zeros, and to do that, well, I'm just going to set the whole thing equal to 0. And then the first thing is to just get rid of the denominator, because if you multiply both sides by x squared plus x plus 1, well, the right side you just get 0, and then the left side it goes away. So then you get 2x plus 1 equals to 0, which is simply negative 1/2. And that's it. Okay, so we want to find the zeros and where this guy doesn't exist. If we're looking for where this guy is undefined or does not exist, probably the first thing we would do is, since this guy is e to the negative x, notice that this is simply 1 over e to the positive x plus 2 over e to the positive 2x. Now, this guy, though, you'll notice that this can never equal 0. And this guy also can never equal to 0. So what that means is that it's defined everywhere. Okay. Alright, now if we're going to solve this guy now, then let's do some math. Why don't we, since we already have it in this form, let's just get rid of the fraction. So if we multiply both sides by the LCD, which would be e to the 2x at this point, we would get, if I distribute this guy, we would have negative e to the positive x, because when you reduce these guys, remember, e to the 2x on top over e to the x, subtract the exponents by the laws of exponents, just gives you e to the x. And then plus 2, these guys cancel, and equals to 0. Okay, and then why don't we just bring this guy over to the right side, and that's going to give us 2 equals to e to the x. Okay, and then to finish this guy off, either get the log of both sides or use the definition of the logarithm to get that x is going to equal to natural log of 2. And so that's where the 0 is. Okay, so we're trying to solve this function. The first thing that we can do to make life easy on us is to factor out the greatest common factor, which in this case would be a 6. And that would leave us with 2x squared plus x minus 1 equals to 0. And so then let's try to see if we can factor this guy. Here we would need a 2x and then an x. and then we need to have a minus 1. So let's put, the only way to get that is to have a minus 1 and then a plus 1. And if you test this, you'll see you have a positive 2x and minus x, which would give you the middle term right here. So then if you set each one of these equal to 0, you get x equals to 1/2. And from this one you get that x is equal to negative 1. So those are all our solutions. Okay, so if we try to first find where this function is undefined, well, we already know that it's defined everywhere from 0 to 2 pi because both sine and cosine are defined everywhere between 0 and 2 pi. And we don't have any fractions or anything like that. So we don't have to worry about that. So if we're trying to find the zeros, I set this guy equal to 0. And you notice, the first thing that you maybe notice is that you have a cosine in common. So why not factor out that cosine? And might as well factor out the 2 cosine. And that would leave you with sine of x minus 1 is equal to 0. And then all we have to do is find, solve each one of these. So we would solve, for example, 2 cosine of x equals to 0. And then we would solve this other guy, sine of x equals to, so sine of x minus 1 equals to 0, or sine of x is equal to 1. Okay, so if we want to know where the 2, we don't have to worry about it because we just divided, but where is cosine equal to 0 between 0 and 2 pi? Well, I know that that's true when x is equal to pi over 2 and 3 pi over 2. And sine of x is equal to 1 only at pi over 2. That's the only spot. But notice that that one's already, we already found that. So it's okay to have a duplicates, but we already had it over here. So we have 2 zeros, pi over 2 and 3 pi over 2. So we're trying to find the zeros of this monster, and you know, you're looking at this guy and you might be thinking, well, if you can factor it, but notice that you have sines and cosines. So the only way to save yourself from the wrath of this problem is to remember an identity. Now, this is one of the most important identities in trig, and it comes up a lot, and that is the Pythagorean identity. That sine squared plus cosine squared is equal to 1. Now, notice that here you have sine squared, cosine squared, and then you have a sine. So what you can do is you can use the Pythagorean identity to turn either sine squared or cosine squared into the other one. But since you have 2 terms have sine in it and only one has cosine, well, the smartest thing to do is to use cosine squared equals 1 minus sine squared. Then that way you make everything into a sine. So if you do that, then you get 2 sine squared and then minus 2 times 1 minus sine squared. If you distribute that, you would get minus 2 plus 2 sine squared and plus 2 sine of x equals to 0. Okay, now to save you a little bit of a hassle, notice that all of these are 2's. Why don't you just divide by 2, turn this guy into a 1, and this makes your life much easier. Well, I guess just a little bit easier. Okay, so then let's combine the sine squared. So these guys would equal to 2 sine squared, and let me put them in order. plus sine of x, and then minus 1 is equal to 0. Okay, now this guy is a form of a quadratic, so we can probably factor this guy. I would need a 2 sine x and a sine x. And then to get a negative 1, we could do a plus 1 over here and a minus 1 over here. So then when we multiply 2 sine x times 1 and minus 1 times sine x, that would give us the middle sine of x. So then what I'm solving is sine of x equals to 1/2 and sine of x equals to negative 1. Okay, so I can do that. Let me over here on the side do a little tiny version of the unit circle here. Okay, so sine is equal to 1/2. I know that the reference angle is going to have to be pi over 6. So, and then positive 1/2, so that's going to be at pi over 6. And then it's going to be over here in the second quadrant, because that's where sine is positive, so that's going to be 5 pi over 6. And then from this one, sine is equal to negative 1 down here at 3 pi over 2. That one's easy. So 3 pi over 2. So this one has 3 solutions, 3 zeros. And that's it.